Let me run through one more example. In this case, we have a firm that produces a single product, but it sells this product in two distinct markets. Maybe the firm is said to be engaging in price discrimination, charges different prices in different markets. It has to be able to separate the two markets and prevent the consumers in each market from arbitraging, from reselling the product. Maybe this is a service that they're providing. Maybe we're talking about a physician or a surgeon who charges different prices to rich people and poor people. Or maybe this is somebody who charges different prices to retired people versus people who are not retired. Senior citizens. You know, I've noticed at the movies, I'm embarrassed to admit this, but when I go to the movies, I now qualify for a senior citizen discount. Okay. So it's the same movie, but they're charging different prices. If you're over 62, I don't know what their age limit is, 60 or what, 55, whatever the age limit is, I'm over it. So I qualify. But you would not qualify. Although sometimes the discounts go to younger people. Sometimes there are discounts given to students with a college ID. So sometimes it benefits you. Okay. So that's what we're dealing with here. Same product, but it's sold in two markets. So you have the demand curve for group 1 is given by this equation. 100 minus Q1. The demand curve for group 2 is given by this equation. 60 minus Q2. Let the cost function be this. The cost function is just 20Q, where Q is aggregate output. Q1 plus Q2. So if I substitute in, the cost is just 20 times Q1 plus Q2. The output you sell to group 1 and group 2 is the same. So your total cost just depends on the aggregate output you produce, not how much you sell to each group. Okay. But group 1 has this demand curve. Group 2 has this demand curve. The question is now, given that you're able to charge different prices to the two groups, what price will you charge to each group? How much will you sell to each group? Okay. Well, how do we proceed to solve this problem? How is this price discriminating monopolist going to behave? We assume the monopolist wants to do what? Lucy? Right. We assume that they want to maximize profit. So our objective function, again, is going to be a profit function. Probably the easiest way to do this, actually there's a choice here. Probably the easiest way to do this problem is to express profit as a function of Q1 and Q2. Although it is possible to do it in terms of P1 and P2 instead. But the easiest way, I think, is to express profit as a function of Q1 and Q2. The reason for that is because cost is already expressed as a function of Q1 and Q2. Okay. So, Ben, what is profit? Revenue minus cost. Now, the cost function is easy because that was given to you. But what about the revenue function? The revenue function is going to be just a little bit trickier to get. What is the total revenue going to be in this case? Yeah, the revenue will be the revenue from product 1, P1Q1, plus, right, plus P2Q2. But this revenue function is expressed as a function of P1, P2, Q1, Q2. How do we simplify this? Yeah, what kind of substitution are we going to do, Ben? Exactly. That way we can get rid of P1 and write if we want revenue expressed as a function of Q1, Q2, we're going to just get rid of P1, P2 using these demand curves over here. That's P1 times Q1. P2 is given by this. Okay. So our revenue function becomes 100 Q1 minus Q1 squared plus 60 Q2 minus Q2 squared. That's our revenue function, expressed as function Q1, Q2. Subtract out the cost function. You've got your profit function. So our profit function is just going to be this. It's 100 Q1 minus Q1 squared plus, what was it, 60 Q2 minus Q2 squared minus costs. So it's going to be a minus 20 Q1 minus 20 Q2. Okay. So we can simplify this profit function just a little bit and write it as this. For this problem, this profit function is our objective function. That's the thing we're trying to maximize. Let me just write it down, and then I'll get your question. So it'd be 80 Q1. Minus Q1 squared plus 60 Q2. No, not 60, because we have 60 minus 20, so it'd be 40. Minus Q2 squared. Yeah, Ben?
We're almost out of time.
Yes.
Can we briefly discuss the exam?
Okay. Well, I could just stop here. Once you got your objective function, that's the hard part. Then the rest is easy. The rest, you just crank through the first order conditions and the second order conditions, and you find your maximum value.